This video will show you how to write chemical formulas for binary ionic compounds. The first thing we need is a couple of definitions. When a metal combines with a nonmetal, an ionic compound is formed. A binary compound consists of only two elements. In Science 10, you'll be given this periodic table. Notice the black staircase. It starts on the left of boron and steps down to the right until it runs between elements 117 and 118. The elements on the left side of the staircase are metals, and the elements on the right side of the staircase are nonmetals. A binary ionic compound forms when a positively charged metal ion combines with a negatively charged nonmetal ion. Now, once we have the formula for an ionic compound, what does it mean? For example, the formula for the ionic compound sodium chloride is NaCl with no subscripts. Subscripts are the little numbers often written to the right and below the symbols in a formula. The formula NaCl does not mean that sodium chloride consists of individual NaCl molecules, like this. Ionic compounds do not exist as simple molecules where atoms are held together by a covalent bond. Ionic compounds actually consist of a large pile of positive and negative ions, all neatly stacked together. The small purple spheres represent Na+, or sodium ions, and the large green spheres represent Cl-, or chloride ions. Even this diagram shows a very small part of an actual NaCl, or salt crystal. This arrangement is called a crystal lattice. Looking at this lattice, you can see that for every Na+ ion, there is one Cl- ion. They're in a ratio of 1 Na+ to 1 Cl-. The formula for an ionic compound gives the smallest whole number ratio of ions. So the formula for sodium chloride could be written as Na1Cl1. Chemists usually leave out the 1 in a formula, so written more simply, the formula is NaCl. Let's look at another example. The formula for calcium fluoride is CaF2. This means that calcium fluoride consists of a huge pile of Ca2+ and F- ions, all neatly stacked, or a crystal lattice. And the formula CaF2 tells us that for every Ca2+ ion, there are two F- ions. Now that you know what the formula for an ionic compound means, we'll show you how to find the formula for the compound with a given name. There are two methods that we'll walk you through here for finding formulas. When you see both of these, you can then decide which method works best for you. The two methods are Method 1, equalizing positive and negative charges, and Method 2, crossing down the charges. Let's do an example of the first method. Finding a formula by equalizing positive and negative charges. So the question is, what is the formula for aluminum bromide? We can set up a little table like this. Now when you're doing this, you don't really need to enter the information on the left. It's just here to help you understand what we're putting in the table. We put the ion names in here, so in this case, aluminum and bromide ions. We look them up on the periodic table and find their charges. We find Al3+ and Br-. We add them to the table. Here, we are using a 1- for the charge on bromide rather than just a minus. Looking at their charges, we see that they are not equal and opposite. They don't add up to 0. When the formula is correct, these charges will be equal and opposite, and they will add up to 0. Now if we add two more bromide ions, so we have 3 bromide ions altogether, the total negative charge is now 3 times -1, which is -3. The charges are equal and opposite now. +3 and -3 add up to 0. So we have the correct numbers of each kind of ion. Because there are 3 bromide ions for every 1 aluminum ion, the formula is AlBr3. Let's do one more example. We're asked to write the correct formula for calcium phosphide. We put in the ion names. Now we find these ions on the periodic table. For phosphide, we use phosphorus with a charge of -3. We add them to the table, and we write down their charges. We see that they do not add up to 0. To find the correct number of each ion, we use the lowest common multiple of 2 and 3, which is 6. If we have 3 Ca2+ ions and 2 P3- ions, the total positive charge is 3 times +2, which is +6. And the total negative charge is 2 times -3, which equals -6. So the charges are now equal and opposite, and they add up to 0. Because there are 3 Ca2+ ions for every 2 P3- ions, the correct formula is Ca3P2. Now we'll do a couple of examples using the other method, which can be called crossing down charges. We're asked to come up with the formula for rubidium sulphide. We find the symbols and the charges for rubidium and sulfur on the periodic table. We jot down the symbols and their charges here. We write the symbols down here, leaving a space between them. We bring the 2 from the charge on the nonmetal down and write it next to the metal symbol. Like this. Notice we don't carry the negative sign with it. We make all subscripts positive. This is what we mean by crossing down a charge. We bring it down and cross over to the other atom. We do not bring the 1 down from the charge on the metal. 1s are not written as subscripts, so we just ignore 1+ or 1- charges. So Rb2s is the final formula for rubidium sulphide. Let's do another example. We're asked to come up with the formula for vanadium 4 oxide. So we find vanadium and oxygen on the periodic table. More than one possible charge is shown for vanadium. Metals with more than one possible charge are called multivalent metals. When the name of a metal is followed by a Roman numeral, the Roman numeral tells us the charge on the ion we need to use. So because the Roman numeral is 4, the ion we use is V4+. Now we jot these 2 ions down here. We write the symbols without any subscripts here, with a space between them. The charge on oxide is 2-, so we bring the 2 down here and write it by the vanadium. Like this. Remember, we leave the negative charge behind. The charge on vanadium is 4+, so we bring down the 4 and write it next to the oxygen. Like this. However, this formula is not correct yet. The formula for an ionic compound gives the simplest whole number ratio of ions. The subscripts 2 and 4 are both multiples of 2, so this ratio can still be simplified. We do this by dividing each of these numbers by 2. This simplifies the formula to VO2. So the correct formula for vanadium 4 oxide is VO2. Be aware that you must always check subscripts to see if it's possible to simplify them. If a formula can be simplified and you don't simplify it, you'll get the answer wrong.